Hi, a couple of you have asked for how to do this homework problem that was due this past Wednesday. So I thought that I would go over the algebra behind parts B, C, D, and E. If you want part A, you can come see me in my office, or feel free to skip around depending on which part you are interested in. So recall, I'm just doing the algebra. So the directions are, for each of the following functions, use the limit definition of the derivative to compute the value of f prime of a using three different approaches. Number one, it says strive to use the algebraic approach first to compute the limit exactly. Notice when it says that word strive, that's sort of indicating that there might be one or two that you cannot do algebraically. And this is for small values. And then test your result using numerical evidence using small values of h, and then finally plot the graph. So we're going to do the algebra. All right, so I think I'm out of order, but no big deal. One of the questions is, for f of x equals square root of x, find f prime of 1 algebraically. So let's go ahead and write down our limit definition. So f prime of 1 is the limit as h goes to 0 of f of 1 plus h minus f of 1 over h. And so let's go ahead and use our function square root of x. So we get the limit as h goes to 0 of square root of 1 plus h minus square root of 1 over h. And let's simplify that square root of 1. Square root of 1 is, of course, 1. Now, what do we do with this? I'm going to go ahead and put this on the next page so that I can write below it. So there's something called rationalizing the numerator. And the reason I might want to do this is because right now, if I tried to compute this limit by just inputting 0 for h, I would get 0 divided by 0. So I somehow want to get rid of that h in the denominator. So the way I do this is with something called rationalizing the numerator. So I'm going to multiply top and bottom by a factor. I'm going to multiply the whole thing by a factor of 1, which means multiplying the numerator and the denominator by this seemingly funny expression, square root of 1 plus h plus 1. So what happens here, it seems like it's more complicated, but when I multiply through, I get the limit as h goes to 0. That denominator is kind of weird. And then I multiply each term in the numerator. So I get square root of 1 plus h squared plus square root of 1 plus h minus square root of 1 plus h minus 1. So make sure that you can get that by multiplying those out. And then you should see you get some cancellation. So first of all, square root of 1 plus h squared is just 1 plus h. Square root and square are inverse functions of each other. And plus square root of 1 plus h minus square root of 1 plus h, those two cancel each other. So we get the limit as h goes to 0 of 1 plus h minus 1. And then you see our 1's cancel. And we get the limit as h goes to 0 of 1 over square root of 1 plus h plus 1, because these h's also canceled after our 1's canceled, the factors canceled. Now I'm ready to compute the limit. The limit as h goes to 0. I get 1 over square root of 1 plus 1, which is, of course, 1/2. So overall, I get f prime of 1 equals 1/2. And that should match what you find numerically and graphically. Okay, let's try another one. Let's try f of x equals sine of x. We want to find f prime of pi over 2. So let's write down our limit definition. All right, we end up with the limit as h goes to 0 of sine of pi over 2 plus h minus sine of pi over 2 over h. And you're probably trying to simplify here. So one thing is that sine of pi over 2 plus h, that takes the sine function and actually shifts it to the left by pi over 2. So that is the same as cosine of h. And then also sine of pi over 2, that is 1. So we get the limit as h goes to 0 of cosine of h minus 1 over h. Now, this is not one we know how to simplify right now. We do not know what this limit is. And so this is the one they were talking about when they said strive to compute it algebraically. We don't know what to do here. We're going to have to use numerical evidence from the table, and also we're going to have to use a graph. Okay? That's the only way that we know how to do this one. So if you didn't know how to do this one, that's okay. That's where you should be. All right, let's try another one. F of x equals 1 over x. We want to find f prime of 1. So let's write down our limit definition. F prime of 1 is the limit as h goes to 0 of f of 1 plus h minus f of 1 over h, our familiar limit definition. So this is the limit as h goes to 0 of 1 over 1 plus h minus 1 divided by h. So lots of fractions here, fractions within fractions. So let's make this a little bit nicer for ourselves. And remember that dividing by h is the same as multiplying by 1 over h. All I did is instead of dividing by h, I made it multiplying by 1 over h. Okay, so now what we want to do is we want to deal with this piece, 1 over 1 plus h minus 1. And in order to do that, we need a common denominator. So we need to remember that 1 as a fraction is 1 over 1. And now we're going to get a common denominator. Our common denominator is going to be 1 plus h. So we multiply 1 over 1 by 1 plus h over 1 plus h. And we get the limit as h goes to 0 of 1 over h times 1 over 1 plus h minus 1 plus h over 1 plus h. And again, I'm going to rewrite this on the next page so that I have more room. Just rewriting the exact same thing. And now I'm going to combine my fractions with the same denominator. So I get the limit as h goes to 0 of 1 over h times 1 minus 1 plus h over 1 plus h. Notice that when I combined them, this piece, oh, I didn't mean to do that. Whoa. This piece, 1 plus h, that went in parentheses because I was subtracting all of it. So now I can distribute the minus sign, and I get the limit as h goes to 0 of 1 over h times negative h over 1 plus h. And now I have a factor of h in both numerator and denominator, so they cancel. So I have the limit as h goes to 0 of negative 1 over 1 plus h. And now, if I input h equals 0, I would not get 0 over 0 anymore. So I can go ahead and do that, and I get negative 1. So f prime of 1 equals negative 1. Okay, and here's how to compute that fractional derivative algebraically. Okay. All right, one more. So f of x is the last one equals 2 minus the absolute value of x minus 1, and we want to find f prime of 1. Now, this is one that's really easier to see if you either do this numerically or graphically. Graphically is a lot more evident. And what you'll find is right at x equals 1, there's a v, and it's a corner point, which should tell you there's no tangent line, and so the derivative does not exist. Okay, but let's see how we would do this algebraically. So again, we've got our limit definition. Okay, we input 1 plus h and 1. And then we simplify, and we get the limit as h goes to 0 of negative absolute value of h over h. Okay, so your expression should simplify to here. So now, how do we deal with this? So I'm going to write it again on the next page. And then I have to remind myself, what is the definition of absolute value? Okay, so absolute value of h is, I'm trying to pause that, okay, it's just itself if h is greater than or equal to 0. It's just h if h is greater than or equal to 0, right? That's what the absolute value is. But if h is negative, then I want to make it positive. If h is negative, I want to take the opposite sign. Okay, and the way we take the opposite is we take the negative of a negative number. Okay, so for instance, if I want to take the absolute value of -4, okay, this piecewise function would tell me -4 is less than 0, so that is -4, which is +4. That's how I would deal with that one. Okay, so here's our piecewise function. So the deal is, in looking at this, piecewise function, or looking over here, you know that the function behaves differently whether h is bigger than or equal to 0 or whether it's less than 0. So we have to take the one-sided limits separately. So that's what we want to do. Okay, so we want to look at them separately. So let's first look from the right. If I look from the right, the negative absolute value of h over h, well, if h is greater than or equal to 0, then the absolute value isn't really doing anything, so I just get negative h over h, which simplifies to -1. Okay, so the right-handed limit is -1. Let's look at the left-handed limit. Okay, if we take the left-handed limit, then h is going to be a negative number. Absolute value of h is going to be a positive number. And negative absolute value of h is going to be a negative number. So I should have a negative number in the numerator and a negative number in the denominator. If I look over here at this piecewise definition, I want the opposite sign of what h is. So it's the limit as h goes to 0 from the left of negative h divided by h, which gives me 1. Okay, so that means from the right I get -1, and from the left I get +1. So the one-sided limits are different, and since going from the left is different from coming to the right, it means that original limit does not exist. Or in other words, that there is no tangent line and the derivative does not exist. All right, I hope this helped. I hope this helped explain the algebra behind those four. And let me know if you have any questions.